All right. Oh, wait. Okay, there we go. All right. So, I'm going to split screen this with Desmos real quick. Not like that. Bigger. All right. Okay, so let's look at a few problems here. Vanessa invested $2,500 into an account that will increase in value by 3.5% each year. If Vanessa does not make any deposits or withdrawals, how much money will she have in the account after 20 years? So, for this, we need to know, first of all, whether it's growth or decay. Which one's happening here, growth or decay? Growth, how do we know? Increase in value, right? So we are looking at growth for this one. So we will have y equals, we will have our starting amount. William, what's the starting amount for example 5? 2,500. Okay. Then we need to figure out our b. Since this is growth, we're going to do 1 plus the rate, but the rate must be a decimal. So Alvin, what is 3.5% going to be as a decimal? 0.035. Perfect. So we got 1.035 to the x power. X is always our time. In this case, it's years. Y is our value of our account, our balance in our account. So we're always going to, for these problems, have like another number that we need to plug in. We got 20 years. Where's that going to go, Drew? X or Y? X. All right. So that makes this one of the easier problems because we're just typing in 2,500 times 1.035 to the 20th power. Okay, so we'll just go to Desmos or your calculator, either one, 2,500 times 1.035 to the 20th power. And we will get 4,974.47. So $4,974.47. Okay. Questions? All right. 6 says a virus has infected 400 people in the town. It is spreading to 25% more people each day. How long will it take until the number of infected people has doubled? Okay. So we need to set up our equation to start with. Katie, what's the starting amount going to be for this problem? 400. Very good. All right. We need to do our B value. Is this growth or decay? Growth that's spreading. So we got 1 plus. Anissa, we need 25% to be a decimal. What's that going to be?
Isn't it just like decimal 25?
Yes. Because right now, it does not have a decimal, which means it's at the end. We just move that 2 places. So 0.25. So that means our B value is going to be 1.25. And we'll have to the x power. What does x stand for this time? Yeah, what are we measuring time in for this one? Not years. Days. Because it tells us that we're spreading 25% each day. Okay, so that's days. This is the first one we've done that's not years, but it could be anything there. And then y, what does y tell us on this problem? That's what we're looking for. It is our number of people that what? Are infected. So it's number of infected people. All right. So what should we do here? I don't see another number to plug in. Okay, we're going to double 400. right? Because we want to know when this is doubled. If we double 400, we get 800. We're going to put it in for the Y. We want to know when there would be 800 people that would be infected. We're going to solve it by hand. I forgot yesterday to check these on Desmos, but I'll show you how to check them on Desmos as well. So if I want to solve that by hand, what have I got to do first? Divide by 400. Which is going to give me 2 equals 1.25 to the x power. Got to get rid of the 1.25. How do I do that? Got to log it. I'm going to log base 1.25. That'll get rid of this over here. Log base 1.25 over here. And so x is going to be log base 1.25 of 2. If I type that in, if you're using Desmos, it'll look this way. Or you could do log of 2 divided by log of 1.25. So log base 1.25 of 2. And we will get 3.106 So x equals 3.106. 3.106 what? Days. So it would only take 3 days to double here, a little over 3 days. Let's look at how to check these on Desmos. I want you to be able to do them by hand, mostly because sometimes the graphs are hard to see on this. Remember, like here was my equation right here, 800 equals... Oh, why is it not on here right? Good gracious. Right here is our equation that we have. The 800 equals 400 times 1.25 to the x. How do I check an equation on Desmos? If I want to solve it without having to do it by hand, how do I do it on Desmos? One side goes in the top line, y equals 800, or f of x equals 800, right? So that's the left side. And in the second line, I put y equals 400 times 1.25 to the x power. Now, the problem with these is that I can't see it, right? The reason I can't see it is because y equals 800 right here. I could zoom out. We can probably zoom out on this one. The problem is if you zoom out, it's kind of hard to see, so you might be a little bit off. This one is showing up with the 3.106. The other thing you can do is if you just need to see more of the y, go over here to the y-axis and make it 800, and then you can see like a better graph there for that. So that's a little bit easier to see instead of just zooming out. But if you forget how to solve these by hand, any equation, it doesn't matter. We're going to do some other really difficult equations. If you forget how to do any equation by hand, you can put one side in the top line, y equals that on the top line, and y equals the other side here, and just look for where they cross. Okay? Questions? All right. Let's go to the next questions here. All right, Elijah invests some money in an account that gets 7.2% APR interest. That APR right there, a lot of times you'll see, and it's going to matter a lot when we get to the second part of these notes we're going to look at today. APR is annual percentage rate. All right, so it is annual percentage rate compounded annually. If he does not make any deposits or withdrawals, how long will it take for his money to double? All right, so a couple things to look at right here. That APR means that we're looking at an annual rate, and we are compounded annually. If those two things match, you don't have to do anything special, okay? We're going to see in the next set of notes that we're going to do today, we're going to have to look out for something there. But right now, we don't have to do anything special. 7.2 is just our growth rate. This problem's missing something. What is it missing? If I go to write this, what's my starting value? I don't know how much money Elijah has. So here's what I need you to do. I need everybody in this room to make up a number to put there. Doesn't matter. Make up how much money you think Elijah has. You can think that he is broke and only has $1. You can think that he has $27.32. You could think that he has $1 million. So make something up. I want everybody to pick something different to put as their starting value. Okay, so make a number up to put there. How many, are you counting? Oh wow, you actually have some cash money back there. All right, so we're looking at what about 45? He's got $45. He's going to use 45.
I guess $45.
Yeah.
I have more ones.
Yeah. So, Elijah, we're going to make up a number. I'm going to say $721. Mostly because I want to pick something I hope nobody else picked. So if I guess he had 721, I'm putting that there. Then we need our B value. Okay? So the B value, this is interest, so it's increasing. We got growth here, 1 plus. Elijah, what would I use as my decimal for 7.2%?
I want to write it down. It would be like
0.072. So we get 1.072 here to the x power. X is your years. Y is your balance or your value of the account. So I need everybody to figure this problem out. It's like the last problem we just did, except for we all just made up how much money he had. Okay? So I need everybody to do that. I am going to freeze my screen so you can't see what I'm doing here. So like I know I need him to double his money. So if I have 721, I'm going to double that, and I'm going to plug it in for my Y. So if you have $45, you're going to double that, plug it in for the Y, right? So so everybody try it on their own. See what you got. Mm-hmm.
When you log it, will it be the number, log number in parentheses, and then log whatever you got after you divided? Or divided by the log, whatever.
Whatever the base is. So like the base on this one should be 1.072. So it'll be log of whatever you get over log of 1.072.
So you put your number first.
Yeah. Yeah. The number, like the big in size number, the one that's in the parentheses, that goes on top. The base, the little number, the subscript, it goes on the bottom. You can type it in. Yeah. Alright, check with your neighbors, see what they got. Alright, anything interesting out of what you guys are seeing? Alright. How many of you got 9.9696 or something that rounds to that? Well, that rounds to the same. You rounded differently than I did. So, if you didn't get 9.9696 or something that rounds to that, rounds to that, you're wrong. You messed up somewhere. I think this is so cool. It does not matter how much money he has. It does not matter if he has $1 or if he has $1 million. It takes it the same amount of time to double. Because who showed their work on their problems? Let me see. You got the right answer. Let's look at why this is. I showed my work up here. Okay? So you can see what I did here. I had 721, so I plugged in 14. Oh, that was supposed to be a 2. 1442. That was a 2 right there, not a 1. Then I divided and solved right there. So if you look at Williams, let's see if this handwriting is.
You can't see my handwriting. It's so bad.
Oh, look.
It's
I
also really long side. It's like no space.
have been a teacher
Yeah.
for a long time now,
Yeah.
and I have seen much worse. This is not that bad, actually. There's probably worse than sitting in this classroom. Well, if you want to know the worst ever, worst handwriting, period, probably the very worst ever that I had was tied between 2 people. Number 1 would be Dylan Wood, Coach Wood's son. And number 2 would be Hunter Simmons, who is Miss Simmons' son. Theirs was so bad, it was awful. I would say last year I would give it to Maddox Bovender. He was super good at math, super genius kid. His handwriting I couldn't read at halftime.
Your pain trying to be quarterback and tell us the plays. It's so funny. It's like it sounds weird when he's Greek.
Yeah.
And you know, like we're used to right. He says it right, and then the pain's like orange.
Yeah.
Orange.
Yeah.
You know what I'm talking about.
Okay, so let's look at why we're all getting the same answers. Look at William's work here. He started with 5,000. He thought Elijah was loaded. Here, he said that Elijah had $5,000, so he doubled it. He put 10,000 over here. Then the first step you got to do is you got to divide by that number. So he got 10,000 divided by 5,000, which gave him 2. What did everybody get right here? Should have got 2, unless you messed it up, right? Because you had doubled it. And so when you divided that number off, you got 2. So on my work, it's the same. Right here, oh, that's the wrong thing. Right here, oh, I got rid of my work. I erased it. But on my work, let's see if it'll come back. There we go. On my work, I had done the same thing. I doubled it to put that number there. So when I divided it, I got 2. And then you're doing the same thing to solve the problem. So if you see a problem like this, where they do not give you a starting value, but it's asking about doubling or tripling or quadrupling, just make up how much it starts with, because it doesn't matter. So if he had $1 and put it in this account, it would take it 9.97 years to double. After 10 years, he would have $2. That's a long time to wait for that single dollar, right? But if he had $1 million and he left it in this account for almost 10 years, then it would also double, and he'd have $2 million, and he had made a whole $1 million, and that would have been pretty good, right? So, so if you ever see one that's missing the start value and it's asking about doubling, this is how you deal with it. You just make it up because it doesn't matter. All right, Manny bought a brand new car in 2018 for $28,750. If the car depreciates by 12% each year, find the value of the car in 2018. Find the value of the car. Oh, I think I wrote that wrong. Because I didn't mean that. That's a dumb question, isn't it? As it's written, what's the answer to number 8? $28,750. I don't know what I was thinking on that. All right, let's fix that and say, let's go 2023. Let's see what it's worth today. Okay. So for this problem, start value is $28,750. What do I use as my B value here?
No.
You're losing. So
No.
Depreciate means we're losing money. So that B value's got to be 1 minus
1 minus the
0.12.
we'll put it there.
That is going to give you 0.88 to the x power. So x is years. Years since when? 2018. And y is value. And so we need to put in 5 because 5 years have gone by. So if we do 28,750 times 0.88 to the 5th power, we have 15,172.29. So 5 years, $13,000 that you've lost in value. But you have to have a car. So, yeah. So, again, you have to participate, you have to have a car. You're going to need one. But it is not going to gain value. So you don't need to buy it like, oh yeah, I'll drive this for a couple years and I'll sell it for more than it's worth. No, you're not. It's not. That is not a good investment plan. You need to look at it like, I am going to pay this for a car and I'm not getting, depending on how long you drive it, you're not getting that money back. You might get some of the money back, but you're not getting all that money back for sure. Okay? All right, one more thing on these. All right, this is pretty basic here. These problems aren't really ones you got to work out necessarily. So, for example 9, the equation v of x equals 255,000 times 0.89 gives the value of a dump truck after x years. Is the value of the dump truck increasing or decreasing? Looking at that equation, is the value of the dump truck increasing or decreasing? It's decreasing. How do you know? Okay, this number right here, this 0.89, this number is less than 1. And if that number is less than 1, value decreases. If that number is bigger than 1, it is increasing. You should also just know that dump trucks are also probably not going to increase in value. So these are not, I mean, if it told you 1.07, then you need to say the dump truck, for whatever odd reason, is increasing in value. But the answers usually also should make sense in the terms of real world, right? So, you know, we know that if you have a dump truck, it's probably not going to become worth more money as time goes on. All right, here's the other question. It's a little harder to do. What rate is the value of the dump truck changing? It is not 89. Nope. No. All right. Now, 89% is the percent of its value that it's keeping, right? So it retains 89% of its value. But when we do that B value, if we have decay, we do 1 minus that rate, right? That rate is what it's asking for right here. So if I got 0.89, I subtracted 0.11, right? So it's 11%. Because if I do 1 minus 0.11, I will get 0.89. So it is 11% decrease. Okay? A way that you can do these problems, if you're having a hard time like thinking of that in your head, if you just subtract 1 from this, it's going to give you negative 0.11. The negative tells you you're decreasing. The 0.11 is your rate on that. Okay, questions? All right, here's another question. We've got this equation. It gives the cost of a gallon of milk in T years after 2000. According to the function, how much did a gallon of milk cost in the year 2000? I meant to ask you this question like this time. What is it? 3.05, because the year 2000, in the year 2000, that's your starting value, right? That's the year you start. So it's just that number right there. You could also plug in a 0. It'll give you the same answer if you plug it in. But you thought a gallon of milk cost $1.30? You need to go grocery shopping. Yeah. Depending on where you buy it and what kind you get, but it's not. I mean, inflation has happened, but not. I get that 2000's a long time ago to you guys. It does not seem that long ago to me, but all right. Is the cost of milk increasing or decreasing? William, is the cost of milk increasing or decreasing? Increasing. How do we know? This number right here is bigger than 1. Okay? What rate is our cost of milk increasing at? 0.7%. Okay? Again, if you're not sure, you can use that same rule. Subtract the 1. It's going to give you 0.007. Since that's positive, you know it's growth. Move that decimal 2 places. There's your percent, 0.7%. Okay? All right. I think we got a few more here. All right, for each one of those, I want you to circle whether it's growth or decay, and then tell me the percent is growing or decaying by.
The rate that it's changing is different than the percentage, right? Or is it the same thing?
Yeah, the rate is the percentage. It's not necessarily the number that you see right there. So like number 11 is not 67%.
Yeah, that's what we do.
100 minus 67, right? Yeah, this one will not be 67. You have to pay it. It's not going to be the number that's right there. To get that, it will be minus the rate. So if you take it minus 67, that'll be what your actual. On this, when you have the percent sign, you don't put the decimal, so it's just going to be 33.
What is everybody did for number 2? Like example 12. Just to make sure I got it right. Huh? I got 68.
Huh?
I got 68.
How did you get 68? No. How did you get that?
I did 100 minus the 32.
No, it's
And then-
blessing.
To take the big number. and
Move
put
your
it
desk.
in rows.
Just, yeah, so with growth, all right. So here, this will always work for this. All right, so if we look at this one right here, this one is decay because 0.67 is less than 1. And if you are going to subtract it from 100, you're going to move that decimal 2 places. 100 minus 67 is going to be 33. Okay? That is your rate of decay. When you have growth, you're really doing the same thing, but you have got to be careful on it. Really, all that happens is like you're taking away that 100. If you want something that will work every time, growth or decay, if you take this and you subtract 1, it's going to give you negative 0.33. The negative tells you that it's decay. You need to move that decimal 2 places. All right. That'll also work right here on number 12. Is this one growth or decay?
It's decay. Or no growth.
It is growth because that number is bigger than 1. So if I subtract 1, it gives me 0.0032. Because that's positive, it is growth. But this is a decimal. I've got to move that decimal 2 places to make it a percent. So it's 0.32%. You're going to have that point. Okay. 13's weird. It's not 300. It's 200. All right, so same rule. Subtract 1. That's going to give you 2. But that is a decimal. You got to move your decimal 2 places. It's 200%. We did on all of them. Yeah, because we're going from a decimal. We're going from a decimal back to the percent, so we want to go to the right.
Okay, but if we're going to percent to decimal.
Other way, yeah. Okay, now, this is tripling. If something is tripling, it is growing by 200%. Okay, what about if something's doubling? If something doubles, what percent is it? Okay, if you are you need to not be working on your computers right now. This is not Desmos work. If you are skipping ahead to stuff, you will miss the stuff we're doing right now. So, don't be working on that. If you have something doubling, it's growing by what percent? 100%. Okay. What about 14? It'll be 75. Because 1/4, if you want to, change it to a decimal. If you subtract 1, you get negative 0.75. It is decay. Oh, this one was growth. It is decay, and it's, move that decimal 2 places, 75%. Okay? What about 15? Too many zeros. It is 0.8. You still have yours as a decimal. So you're going to subtract 1. That is going to give you 0.008. So we are going to have that in part of our work, but that's the decimal. You got to move it 2 places to change it back to a percent. So it'll be 0.8%. And that would be growth or decay. That one's a decay because you're less than 1 there. Okay, questions? All right. Let's, just to take a break from just sitting and listening to me. So, go ahead and finish that up. Close your computer on that.
There's 6 letters and missing 1 number.
Okay. So, remember that on your test that you guys are going to have on Thursday, you can use a note card. Tomorrow, what we'll do at the beginning of class is we'll put a bunch of things on the board that I would suggest putting on your note card. This is one of them, is having this formula, okay? So in this formula, P is your principal. Oh, sorry. This is your compound interest formula. It is generally pretty much always used with like banking sort of scenarios. It's not going to really be used in a lot of other places. So they call P principal. This does not mean Miss Burton. It means it's just really your starting amount still. Okay. The R is your growth rate. This is only used for growth, not decay. You won't have compound decay. It's your growth rate as a decimal. Okay. N is the number of times compounded per year. T is time, and A is amount in the account at time T. Okay, this is going to be similar to what we've already been doing. I don't usually teach it with a formula. I usually teach it another way, but since I'm going to give you the note card, I'm going to give you the formula. The reason I don't teach it with a formula usually is because students have a hard time memorizing that formula. I'm going to give you the formula. I don't think they give it to you on the final exam, but I also realize that's not till December, and the likelihood that you memorize this and keep it memorized all the way till December is low, so we'll kind of do a little bit of review and memorizing things right before the exam. So it's still similar. That P right there is like your A value. This stuff right here is like your B, and this is like your X. Okay, so let's look at a problem for this. And this is some real life stuff, because if you go to a bank, a lot of times they do not compound interest annually. They usually do compound it more frequently than once a year. So Laura deposited $12,000 into an account that earns 8% interest. Now, they really should, I didn't rewrite this problem, they really should tell you 8% annual interest. I am certain that's what it means. They are not going to give you 8% quarterly interest. If you find a bank that's giving that, put all of your money there, you're going to be rich. Right? So annual interest. How much money will she have in 5 years if that interest is compounded quarterly? Okay? So, if we're looking at that formula, A equals P times 1 plus R over N to the N times T. Okay? P is the starting amount. What is our starting amount? 12,000. Okay. Then we're going to have 1 plus R. What is my R? It is rate. What is my rate here? 8%. I need to change it to a decimal. What's it going to be when I change it to a decimal, Andrea? 0.08. Okay? Now, N is the number of times compounded per year. For quarterly, how many times is that per year? 4, right? 4 quarters in a dollar. 4 quarters in a year. 4, each quarter of the grading period there. So that's 4. All right? And so then we've got N times T, so we've used the 4 again. And the time in this case is going to be 5, right? 5 years. Essentially what this does is it makes your annual rate a quarterly rate, and instead of having the number of years, you have the number of quarters up here, right? 4 times 5 would be 20. There's 20 quarters in 5 years. But you don't have to think about that too much. We can type this into calculator and or Desmos here. If we use, I will warn you with the calculator, be a little careful with your parentheses if you use the calculator. If you're using that calculator, Yeah, if you're using the calculator, get back here. All right, you're going to do 12,000 times. Actually, I would do this first. I would do 0.08 divided by 4, and I'd add that to 1, so that my equation now looks like this: 12,000 times 1.02. To the, I'd go ahead and do 4 times 5 is 20, just because you can do that so easily in your head. This is way easier to type in. Answer is going to be, if you do second negative key, that'll bring the answer up from the line before. So 12,000 times 1.02 to the 20th power. I would not try to type that whole thing right there into the calculator, because you got to have double parentheses around that and then raise it to an exponent, and I just feel like that's going to go badly for most people. So I just did this part first. I did 0.08 divided by 4. It gave me 0.2. I added 1 to it. That gave me 1.02. And then I just typed the rest of it into the calculator. We get $17,831.37. If you do, I would highly suggest using Desmos for that, because Desmos makes it look like it's supposed to look. In this calculator, if you miss a parentheses, it's not going to really, you're not going to realize that you did it, and it's going to give you a crazy answer. Yeah. Yeah. So if you type the whole thing in from here, I would use Desmos, because you can see better whether or not it looks right for that. Okay, questions. The more frequently something is compounded, the better it is. It's going to give you more interest. Now, it's not going to be a huge difference. Okay? All right. Let's do, I'm going to just set up this second one real quick, and we're going to move on because I want you guys to have a little bit of extra time here. So, suppose you invest $750 into an account that pays 3% interest, compounded weekly. Okay? So, and any interest, assume that is annual unless they tell you otherwise. I will try to make sure, like on quizzes and tests, that I write that it is annual, but this did not. Oh, I skipped. Skip on down here to 4. We're just going to skip to 4. We don't have time to do this many, so skip to 4. We'll do this one. They're all a little bit different, but it's all that same formula. Okay, so for this, we're using that same formula. So we're going to have our amount is going to equal, what's our starting value? 750. We got 1 plus the rate. What's my rate? 3%. What's that? What is it as a decimal? 0.03. Divided by, weekly. How many times a year is weekly? It's 52. Okay? You might want to make yourself a list of the different things that you can have. We might do that tomorrow. Weekly is 52. What if it was daily? 365. So, like, we'll make ourselves a list of that tomorrow, because that'll be good to have on your note card also. Hourly would be. I won't do that to you, but they could. They could. And so we would raise this to the 52 times our amount of time, but we don't know what the time is this time. Okay? So, I'm going to also show you a little bit of a shortcut you can use on Desmos here, because I don't really want to solve that. But let's go ahead and do 0.03 divided by 52. Oh gosh, let's not do it. Alright, let's use Desmos. It's giving ease over here. Alright, let's use Desmos for this. As long as you type them in correctly, yes. So for Desmos here, alright, for Desmos, here's what I'm going to do. I'm going to type in my equation. I'm not going to use an A because Desmos doesn't know what to do with that A. I'm going to do 750 times 1 plus 0.03 divided by 52 raised to the 52, I'm going to use an X instead of a T because Desmos does better if we use X's. All right, and I'm going to, all right, I want to see, all right, so that's my equation, and I cannot see it right now. I don't know where it's at. But what was my starting value? 750. So if you hit the wrench up here in the corner and go down here to your y-axis, I know I at least need to go up to 750, right? So if I go up to 750, then I can kind of zoom out from there and I'll get a better picture. If you just zoom out, if you don't do that first, you won't be able to see it very well. So I could solve this by hand, but I want to know how long it takes me to have $1,000. Right there is 1,000. It's hitting right about here, right? If I type in y equals 1,000, oops, that's 100. 1,000, I can just use the intersection on that, so I don't have to solve the whole problem. Okay? On compound, I definitely suggest that because they're harder to solve. Okay? So, what was I getting there? 9.592. So 9.592, and this is going to be years. Okay, questions there? All right, one more little thing to show you. And that is this formula here. Okay, so William just a minute ago was doing something that really has to do with what this is right here. Because I said that this problem was weekly and you said it was 52, and then I said daily. And then what did you say? Hourly, secondly. Okay, I'm not going to make you do that. And we don't have time. I do have a short little video. We may watch it tomorrow if we got time, but we may not. So the idea, it's a whole calculus idea. The proof of it is calculus. It's a little hard to explain. But we can compound continuously. Okay? So, every second, every millisecond, every division, tiny nanosecond, right? So if we do that, it's called compounding continuously. And if we compound continuously, we do not use the regular formula. We use this formula. A equals PE to the RT. It is the PERT formula. Long time ago, they used to sell PERT shampoo. I don't know if they still sell it or not. They used to have all kinds of commercials for PERT. It was like the newest technology, shampoo and conditioner in one, which all women know doesn't really work, and all men are like, yes, sounds good, fewer bottles. If they're marketing to men, they're like, shampoo, conditioner, body wash, toothpaste, all in one. Just use this one thing to clean every part of your body. Women are like, for women, they're like, you need shampoo and you need conditioner, and every so often you need to do this hair mask, and you need to have this product and that product, and leave-in conditioner and heat protectant, and you got like a whole basket full of stuff that you use for your hair. Meanwhile, men have one bottle that they're using. So anyway, this was a big thing. Like this technology came out whenever I was probably young, and there was still like TV commercials. I can remember seeing these all the time. Anyway, PERT formula is what we're going to use if it's compounded continuously. All right, so I actually think it's easier than some of the others. Right? Remember, E is a number in your calculator. So Adam invests $1,051 in a savings account with a fixed annual interest rate of 6% that is compounded continuously. So if you see compounded continuously, you are going to use Y equals PE to the RT. And for this, P is still your principal. It's what you start with, so you'd have 1051. E is a number in your calculator. You're going to use that number in your calculator. R is the rate. It needs to be a decimal, so it's going to be 0.06. And then your T is your time, and that, in this case, would be 8. So if you type this in, it would be 1051. On the calculator, if you do second division, it gives you the E to the, put some parentheses right here, 0.06 times 8. Or it's, Desmos may be better to type it in because it shows you it looks right. So he would have $1,698.49. $1,698.49. Do you have parentheses around your 0.06 times 8? Yeah. Desmos may actually be better for typing in because you can see if it looks right. Okay, so if you see continuously, you want to use this formula right here. Okay. All right, questions? All right. I'm not going to do all of this because